so just give you a brief update. We got some stuff going on in the shop this week. Unfortunately, tubing is not in stock for the lower control arm belts. It's gonna have to wait a week. But I was told that they'll give me a call as soon as the 1.25" DOM is in stock, and we'll be ready to rock and roll and getting some stuff built. So we'll go on an overview what we got going on with this bad boy. Got the tube bender back installed, and then we can also go through what's going on with this. So stay tuned. This is episode number 3 of the C1500R build. Just getting some prep work for the lower control arms, and then the next episode we're going to go ahead and start building those. So hope you enjoy. Okay guys, so it's late at night. I got some pipe couplings that are ready to go with some little grease fittings. And I'm going to install those right here, like this, on the side of the lower control arm tube. And that way I can pump some grease into that shaft periodically. So we're just going to drill a little hole in here. I'm going to try to cope that pipe and then do that on both sides of the lower control arm, get it all dialed in, and hopefully we are able to pump grease into this thing pretty easy. My buddy has some material. He's out making shafts for it. I should get those over the weekend, and then we'll be able to progress with this thing. So keep her going. Okay guys, so we got the little hole here. It's like a 3/16" hole drilled on this side and drilled on this side. I don't expect this to flow grease perfectly evenly through this tube because it's longer on the one side. But what I can do is, with this design, the lower control arms will be just fitting loosely on that shaft. If you want to grease it, I can always just torque the lower control arms a little bit tighter, and the shaft will just slightly touch and seal. I can then pump grease into them, and then when I'm done, loosen them back up. Not ideal, but this center tube in here with all the reinforcement is enclosed, and if I wanted to grease the shaft going through it, I would need access to that, which technically I have cutouts down there, and you could fish like, I don't know, like a capillary tube in there, do something nifty like that. But I don't want that kind of stuff hanging out from underneath the truck, because this will be one of the main jacking points on the truck, and we want that to be able to be serviced. So we also got these little pipe couplings, and I have them notched just to go on like so. They're not perfect, I would say, but they're pretty darn good. It'll draw in nicely, and a little bit of just a tack and a little bit of filler will pull those in just fine. So we're gonna go get the extension out, get everything plugged in for the welder. I need to get gas for this welder. I'm on my last 250 PSI, so this is a perfect little job to finish up the bottle. And I think this is coming along nicely. So this is how I got this fixtured up. It's tied down to the table. It's pretty sturdy, so let's see if I can weld these up without making them look like dog crap. So I'll give this a whirl, try to keep posted, and we'll see what we can do them. Okay, so I got these installed. I never said I was a welder. You can see I didn't put a whole lot of filler in there, but I'll tell you what, it's hard to get in this little spot right here. Stuck the tungsten way out. I need like a Furic cup, like one of them big gas lens cups. Right now I'm just running gas lens, but it's a standard like number 8 cup. This guy over here, same deal. I actually ground this down because, you know, being a welder being a grinder makes me the welder that I ain't. So whatever. But these are installed. It's good enough. I'm not a pretty welder, but it's functional. So what else do you really want? These are pointed down. So good enough for now. Okay, so we designed up these little risers for the bottom of the fixture plate. This is the rear one, so it's the tall one. There's another one printing right now that's a shorter one that also bolts to the front of the fixture plate. And what this is going to do is that gives us a 10-degree angle to cut the ball joint sleeve cut, or the ball joint sleeve diameter on for when we TIG weld the lower control arm. So it's a 10-degree slope on the kingpin inclination angle. So we also need a corresponding 10-degree offset on the ball joint sleeve in order to offer a full articulated motion and also to keep the ball joint in the center of its travel. So this is all the farther that I got because my Prusa threw an error. It said I had a thermal heatsink error. So from what I can gather, I replaced this fan a little bit ago, and if the fan's not set up correctly, it can overcool the hot end on the end of the extruder, and it'll read basically too low of a temperature. So I went ahead and blocked some of it off with electrical tape, so I'll see if I can get this thing sort of running better. See if we can get it the rest of the way complete. But yeah, so just burn plastic, burn time. I need to go to sleep because the spool's almost empty, and I need to swap over this spool because my other filament hasn't come in yet. So hopefully burn some more plastic here and maybe not have another failure. We'll see. So I came downstairs, and sure enough, my printer ran out of filament. Where did it run out of filament? Well, this little post right there is half an inch. See if I can get the focus. Half an inch from that surface. This one over here is 485 thousandths off. Or 480 thousandths basically from there to there. So we glued washers on. Now the angles aren't right, but at least the contact point's right. So I'll only be able to bolt it on the front. And then when you sit the plate on it, like this, it'll sit and touch this edge of this washer, but typical. It's my luck. So the printer does have a function that it can like repeat when it can start off where it left off. And if you have the filament in there, but when the printer ran out of filament, it got jammed in the nozzle, so it wouldn't eject it. So this is what we have to deal with. Nothing's ever easy. Okay guys, so we got the second riser installed on the plate that sets the whole thing at 10 degrees. Now it's not all wibbly wobbly. And you can see here, this hole saw fits nicely into our guide here. So that's going to be used for cutting our tubing once it's bent. And then we'll install our lower ball joint sleeves here. So this will be where they'll be mocked up for TIG welding. We're just going to tack in the fixture here and then pull it out. In the rear, I have custom shafts being machined right now by my buddy John that will run the full length of these, that will keep both rod ends square in the fixture. And the shaft will keep them square to each other, or parallel to each other and concentric. This will locate it in the proper position. So the job of these little rises here are only to keep it positioned from the lower ball joint the proper amount. The actual holding it straight will be done by the shaft. Tubing update. I called to try to get tubing this week. They're out of stock. So they said they have an order of 1 1/4 inch, 120 wall tubing coming in this week at like Friday. So maybe Monday I can get tubing in and get that going. But we did get a fresh bottle of gas from Praxair. So basically, I'm just waiting on that tubing to come back in stock, and we can mount the bender back up on the bench and start getting to work. And we're going to try to make this driver's side lower control arm. And then after that, we will proceed and try to make the passenger side lower control arm. Then we need to save some money and see if we can get the rest of the parts on order to finish out the whole front suspension clip. And then it's time to mock it up on frame rails. So I got these back from my buddy John. He went ahead and countersunk a set screw in there. and it's staked and Loctited and all sorts of good stuff in there. And that gives us a way of turning on a nut with a nylock on it on either end while still holding the shaft still so it doesn't rotate while you're doing that. And on this end here, we're going to run a threaded collar with it's like a threaded collar with like a C-clamp, and that'll lock it down. So these are our custom lower control arm shafts. He's got them turned to a thing of beauty, and it's a shame that I'm just going to stick them inside of a sleeve and you'll never see them. But they look really nice. Okay, so you're probably wondering, why do we need a custom shaft? Normally you just pass a bolt through this end and you'd be done, right? But I wanted to be able to change the lower control arm lengths on the fly without having to pull the steering rack. So ideally I could just pull this shaft, rotate these heim ends a set amount of turns on each one, and lengthen or shorten my lower control arm, changing camber, changing roll center, doing all sorts of stuff like that with those adjustments. What you'll notice is that with these nice turned risers that my buddy Calvin made me, we are very tight in here. Now there is clearance at the center of the hole, can't tell from the side, but it's tight. So this can articulate here around the pivot. The pivot is past the center point, so there is no movement during suspension travel. During turning, this rack will move in and out, but that doesn't change the location of this pivot. It just elongates it and actually makes it thinner, that it touches less. So with this shaft, there's just, I bet you could slide a piece of paper between it when this shaft is in there and holding these heims, they're not heims, these bushings ends on, and that is exactly what we were going for. It's compact, but it works. Nothing's touching, clearances are good, and generally speaking, I'm really happy with the fitment of this and just the general quality so far. So we'll mock it up here and show you in a little bit more detail how it looks. Okay, so this is mocked up. Unfortunately, I did try to turn the nut and the Loctite spun. So what I'll have to do is I'll pull this off, clean the black oxide coating off of it, and then just put like a little tack weld on it, and that'll keep it so that when I try to turn this nut in, it won't rotate around. So right now the nylock's actually stronger than the red permanent Loctite on it, so it is what it is. But tack weld, it will not be. So we got this all mocked up here, and these look great. What you'll notice is that the boot is touching right there. So when this is actually put on for real, this won't be a nut, it'll be a round collar with a set screw. So it's a threaded collar with a set screw that locks it on, and it's got plenty of holding force for all of you guys that are hating and saying, oh, don't run that, but it's fine. Trust me, it's fine. But what you will notice is that even though it's contacting right there, one, that shaft should not rotate. The bushing should rotate, not the shaft. If I turn this in, which is hard to do on camera, you'll notice that the accordion there doesn't move, even when we're rotating it around. So that should not wear, it should not cut through that accordion there. Generally speaking, I'm just not worried about it. It's going to be fine. So it was designed, I knew it was going to be tight. It is absolutely as tight as I thought. That's why we had to go low profile and do all this stupid stuff. But it's what I wanted, because I wanted a 6-inch wide crossmember rather than the traditional Mustang 2 4-inch wide crossmember. And I wanted these particular rod ends that have urethane inside of them rather than a solid rod end, because I didn't want it to go thunka 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 down the road. I wanted something like that. I wanted the correct Ackerman. So this is the way it fits. This is the correct packaging. It's tight. It's meant to be tight. It's designed like this. The full model basically shows how this is all going to fit up. But so far we're looking good. Check it out.